So this is the first lecture, online lecture for the student of MST. So let's see how can you can understand. So the first class is on forces, reactions, and equilibrium. First, force and reactions. First is external force. I'll explain in the later slide. First, axial force, transverse force, inclined force, moment, and torsional or twisting forces. These are the external forces. Internal forces is axial or normal, which is generally tension or compression, works along the main axis and perpendicular to the cross section. Now, shear force works at transverse direction, not triggered at this level. Then, bending moment also not triggered at this level. And reactions can be horizontal, vertical moment, or it can be parallel to plane, perpendicular to plane, or moment. At first, let us make you some orientation with the actual scenario. The real beam is like this 3D. It has x axis, longitudinal axis, y axis vertical, and z axis. But once we work with 2D, the picture becomes like this. The z axis doesn't remain. You see, this x axis and y axis. But in level 1, generally we aren't bothered about the height, so y axis doesn't come. Basically, it comes only x axis, that is longitudinal axis, basically. Now, once we consider the point A, say A is this point, actually it is z axis. As we are working in 2D, so we are not bothered about the z axis. Now, what is axial force? You can see a circular cross section beam is pulled from both sides. So once we cut, we find this stress. This yellow line shows the stress. In 3D, force will be something like this. Now, in internal force will be equal to external force, and stress will be sigma is equal to F by A. Probably you know it. And this is called normal force. Why normal force? It is perpendicular to the cross section. Perpendicular to the cross section A. It may have tension or compression. The tensile stress, once I pull from both sides, this will try to effect the tensile force, and if I push inside, it will show a compressive stress or compressive force. Now, transverse force. You see, this is a beam. The force is coming. Transverse means as perpendicular distance with the longitudinal axis. These are the reaction force, I mean internal force, and this is internal stress. This is also an example of transverse. So why? Because this screw, it is working a sort of beam. This plate is pulling this side, and this plate is pulling this side. So there is a process of cutting through this cross section. So this is also transverse force or shear force. If I show you in the 3D, if it is the longitudinal distance, longitudinal axis, vertical force from here, this will make the transverse force. This will create the transverse force, and ultimately shear stress or shear force. Now bending. This is a beam, so I bend from both sides. It becomes like this. It bend, and it has a, we call this flexure also. It has a bend shape. If I cut it and make a free body, we find there is a stress inside. This bending or flexure stress is a bit different from purely axial force. Why? Because in the axial force, if we can see, if we go back, we see whole cross section will experience either tensile stress or compressive stress. If my force is tensile, it will have a tensile stress. If my force is compressive, it will have compressive. But in case of bending, it is different. See, this is the neutral axis. Neutral axis, say centroid. The top portion is compressive and bottom portion is tensile. So it is also normal force, but the whole cross section doesn't experience the similar force. Similar means one part compressive, one part tensile. Now torsion. Say once you give a force to dewater your cloths, it is like torsion. So the torsion, the force is the moment is given along the x-axis, about the x-axis. So it is, if you, the example can be given with the propeller shaft of the vehicle and also rotor of the helicopter, all those. Now, if I differentiate between torsion and bending, you see, torsion is giving moment or giving twist along x-axis, and in case of bending, it is given here. It is given bending or it is given force along z-axis. Actually, we cannot see z-axis in 2D. So it can be z-axis, it can be also y-axis, both. As we are not dealing with 3D object, so we say z-axis. In general, we call a point, and torsion is along x-axis. Now, the types of supports. You can see in the table, there's 5 types of support: roller support, pin support, and fixed support. You know all about this. Roller support, it has only one reaction, vertical. Pin support, or we can call hinge support, it has two reaction. One is vertical, one is horizontal, and fixed support has three: one vertical, one horizontal, and one moment. I'll explain this later. Simply support. The simply support means just one beam is resting on another. Generally, if it is smooth, it will have only vertical load. And link support. Link support is something you are pulling with a wire from a point. It is sort of link support. It has only tension and along the direction of the wire or cable, whatever you call it. Now, simply support has got some other characteristics. I will explain here. Simply support. If no friction works, what does it mean? If no friction, both plane of contact are smooth and frictionless. In reality, it is not possible. But for the assumption purpose, in the first 1 to 4 chapter, the problem we are solving, that we assume frictionless. So the free then only a reaction force works at the perpendicular direction of the plane of contact, like this. But if friction works, which is in reality, both plane of contact are neither smooth nor frictionless. So then reaction force works at the perpendicular direction of the plane of contact, like this. Then we call it normal force. And another force, frictional force, works along the direction of the plane in the contact, and it works opposite to the direction of the tendency of move. So the difference is, in if it is smooth, we have only vertical force, we call it reactions, and if it is not smooth, then this force will work, then we call it normal force, and along this it will have a frictional force. Now come, say a beam. One beam is horizontal, one is inclined, one is vertical. How do you show the reaction? You see, this is vertical is y direction and horizontal is x direction. So as it is roller support, it will have only one reaction, ray towards vertical. But hinge support has two reactions. One is vertical, as it is B point, I have written RBY, and a axial force RBX. These are the reactions. If it is inclined, you see, the RAY, RBY, RBX, it remains same, but it has changed direction. This is Y direction. So I have write Y dash. Y dash means this is not perfectly vertical, it is inclined Y. And this is inclined X. So I have written RBX prime. It is RBY prime. But in case of if it is vertical, then what happened? You see, same thing. Only this is RBX, this is RAX, and RBY. Here it was a Y. In Y direction we had two force. Here in X direction we have two force. That's all. If it is a cantilever beam, that was a simply support. This was a simply supported beam. Now, if it is a cantilever beam, cantilever beam, three reaction force will work on the support. Fixed support. Cantilever beam is fixed support. One is vertical, one is horizontal, and one is moment. I'll explain this moment. If it is inclined, again similar. One is along the plane, along the longitudinal axis, one is perpendicular to the longitudinal axis, and moment remains same. It doesn't make difference if it is also inclined. And if it is vertical, similar thing. Rx in x direction, Ray in vertical direction, and moment. Say in three cases, Rax and Ray has changed its direction, but moment, whatever we look at, it is only considered whether it is clockwise or anti-clockwise. In all three cases, I have assumed clockwise. You can assume anti-clockwise also. Now, forces and hinge joint inclined member of the frame. Say you have a frame, because our next lecture is on free body and frame. So I just explain something before. Say this is a one of the member of the frame and both are hinge. So how the forces works at this hinge level? I have told you hinge correction. I have separated. It may have two way. Number one, you can write the force like this. The two reaction will be there, two force will be there. One is along the horizontal direction, not horizontal, along the line of axis, main axial direction, and another is perpendicular to this. The direction is this side or that side, it is not main here. Only you remember one is along the line of axial direction and another is perpendicular. We can also do it like this. One is vertical, one is horizontal. It depends on the problem, which one will be better for you. Now, force and joint a member of frame. His connection at a joint or frame, two force, horizontal and vertical. Case 1. Actually, I am teaching you for taking the benefits. That is, if you understand this one, you can very well solve the problem of frame quickly. Case 1. No force work in the beam. Say this is the beam, this is the beam, this is the beam. No force is working. So you can say in case of horizontal beam, very simple. One vertical force, two vertical force, one this side, one this side, and two horizontal force. In case of vertical member, two horizontal and two vertical. And inclined also you can write in the same way. Actually, these all three are same. Only you have changed the direction. This is inclined, this is horizontal, and this is vertical. You see, in this case, this red marked area, red circled or red ellipse area, is all these force will be zero. When? Case 1. When no force work in the beam. There is no force. You see, no force here, no force here. If no force there in the beam, inside the beam, then this will work. So the all these transverse reactions or transverse force at the hinge joint. Why transverse? This is the axis and this is perpendicular to the axis. This all force will be zero. But if you write this force like this, then it will not be zero. You can very well test this one by taking a moment. However, you can very well test this one if you take a moment from here, from this point, you find that this force into this distance is equal to zero because there is no other force to balance. So, in all cases, if within the member there is no force, the transverse reactions, I don't say reaction, I say transverse force will be always zero, but not in this case. Now, dealing with the inclined forces. Say this is a member, you have inclined force F. You can do it in two ways. One is theta, one is with the slope. Y is the vertical slope, X is the horizontal slope. If I give you the slope, or if you can find out the slope, you can convert it to the angle also, or with the angle, if it is possible, you can convert the slope. You can do anywhere. You see, this is theta, so F cos theta will work along this, and F sin theta will work along this. And in this case, Fx will be, you see, this is R. At first, what is R? R is, according to Pythagoras, x is root over x square plus y square. So it is a rectangular, it is a 90 degree. So it is a perpendicular. As is 90 degree, according to Pythagoras, x square plus y square is equal to R square. You know it. So you can very well find R. R is equal to root over x square plus y square. Now, if you know the F, what will be Fx? Fx will be, you will divide F by R and multiply with this force. Actually, this is sort of, it has come from the similar triangle. If you know this force, F, you divide with R, and to know this component, you multiply with X. Same is the case with the Fy. You know F, so divide by R and multiply by Y. So you can very well find it. So at the same time, the situation may come. If you know Y, you know Y, Fy. How to find out Fx? Very easy. You divide Fy with Y and multiply by X. Now, dealing with the inclined force, this is the, however, I explained it. Now, dealing with perpendicular force on inclined plane. So this is the inclined horizontal, this is inclined plane and perpendicular force. So I can tell this is theta, similar way, and this is the slope xy. Now, how I resolve this problem? You see, it is F in this direction. This inclination is theta. Remember, this is will be theta, this will be theta. Why? Because this is the parallel and this is the intersecting line. So this angle and this angle will be equal from the geometry. Again, you come, this is 90 degree and this is also 90 degree. So if this is 90 degree and also this is 90 degree, so if this is a common angle, so this theta will be also here. So you can find if it is theta, if it is F, it is F cos theta and it will be F sin theta. Here, once you draw a perpendicular line, the slope becomes opposite. That is, y become x and x become y. So you can very well find out what will be the forces. Fy will be F by R, as y is vertical, so x will be multiplied. and same is the case with the fx. Fx will be f divided by r into slope of this side. Slope of sorry, I have made a mistake. This will be y. This will be y, not x. This is x, okay, because this slope is x and this slope is y, so this will be y. So that's all about the inclined plane force. Now the concept of moment is very important. Actually, introductory level, we deal with 2D XY plane as I have told in the initial stage. 2D plane object, XY plane, but which is actually 3D, that is XYZ plane. So we consider moment is bending against a point. Actually, it is Z axis. We cannot see the line, so we say it point. If I go back to that slide of 3D, you can see this is, if I take moment about A is a point, actually it is Z axis. You will not record Z axis now, but you will be requiring in the subsequent classes. So let me go back to my present lecture. Now moment. There is, we express this moment, word moment, in four places. What are those? Number one, moment you have learned from intermediate. Force into distance, F into D is a moment, and its unit is pound feet or kilonewton meter, something like that. One force and one length. Force into distance. Now couple. What is couple? It is also a moment. Two equal and opposite parallel force also create the effect of moment. I'll explain in the next slide. Moment of a reaction. Moment of a reaction is the, if there is a fixed support, we have three reactions. One is vertical, one is horizontal, and one is the moment. It is that moment. It resists the moment which works at the fixed support to balance effect of all other moment working towards or against the direction. Now taking a moment about point, you can say it is an operator, sort of. It is a third equation of the static. Equation of static to keep the body under equilibrium. I'll explain in the next. Moment explained. Say force into distance, its unit point I have told. Taking moment about a point means actually taking moment about z axis I have told. Now say this is the figure 1. Moment clockwise positive, we will generally consider clockwise positive. So if I take moment about A, this is A, so we'll get 10 into 5 plus 20 into 15. So it results 350 feet moment. Resultant of this moment will be clockwise. So we'll write 350 feet clockwise. That's all. Then go to B. If we take a moment from B, we'll get only one force because this 10 kip force is on the point B. So it will be 20 into 10 clockwise. So it is 200 kip feet moment. Resultant of this moment will be clockwise. So we'll write 200 kip feet clockwise. Now if you go to C, if you take the moment from C, this 20 kip will not come, only 10 kip into 10, 100. So, and it is counterclockwise or anti-clockwise. So C will get a moment anti-clockwise. So write 100 kip feet anti-clockwise. This is how we express the moment. Now couple. Say this figure 2, there is 30 kip, another 30 kip. They are parallel and opposite direction with a distance 10. If we take a moment from A, in figure 1, force will be 30 into 5 clockwise plus minus 30 into 15 anti-clockwise. So it becomes minus 30 feet moment. Minus 30 feet means as I have taken clockwise, it is anti-clockwise. Minus means it is opposite to assumed direction. I assume clockwise, The answer is minus, so it is anti-clockwise. Now come, if I take moment from B, what happened? 30 into 10 anti-clockwise. You see, my point is at B, so only 30 kip force will be utilized and the distance will be 10. So 30 into 10 is minus 30 kip feet. It is also anti-clockwise. If I go to C, you see 30 into 10 anti-clockwise. In all three cases, the force is same minus 30 kip feet and it is counterclockwise. So wherever is the case like this, the answer will be always 30 kip feet, and from where anywhere we take moment it will. So instead of writing this, we can very well write 30 kip feet moment symbol like this. We can write this moment about this. So in the problem sometimes we give some this symbol, that means actually something like this. So in this case, we can get moment from all points. So it is couple whose value is 30 kip feet anti-clockwise. We can draw figure as figure 3. Now equilibrium equation of the statics. This is the main thing with which you will travel up to level 4, that is full engineering in 2D plane. In case of 3D, there are other equations I am not going to explain in this slide. The first static equilibrium condition for a rigid body expresses translational and rotational equilibrium. What is translational? Translational means move from one point to another. It may be vertical, it may be horizontal. So there is two. One is horizontal, one is vertical, and rotational means it will not rotate. It will not rotate like this. So first horizontal translational is summation fx positive right side. We'll assume this. You can assume opposite side also. It is convenient to consider always right side. And summation of all forces along x direction is 0. The meaning of this is we take moment, and these equations may be utilized for a point or maybe for a body. It is applicable for both. However, now Fy, summation Fy, there is a mistake. It will be positive upward. A clockwise symbol has come here. Actually, this symbol will come here. However, Fy, summation of all forces along y direction is 0. You have understood, I believe. Now, and moment, this symbol will come here. This clockwise moment is 0. Moment at a point, any point will be 0. Summation of moment of all forces about any point is 0. Actually, I have not written any point here. If I go to the problem, if we take moment from any points, it may be A, B, C, whatever. If I take moment from a point, the total moment will be 0. Now, what are the moments comes? What are the moments comes? If I go back here, the moment comes if I take a moment from A, all forces transverse direction will come in the moment, and also if there is a concentrated moment like this, it will also come in the moment equation. And also if there is the reaction moment, as I have shown you here, this moment, this will also come. So whatever moment is there, all types of moment will come in this equation, and summation moment will be 0. And I repeat, if the moment is the moment equation is taken, it will be 0 from any points A, B, C, or anywhere. However, it is a partial problem, so I am not going to explain here. The couple explained, moment explained, and these are the equation, the fundamental equation at any static equilibrium. What is static equilibrium? Static equilibrium, a body will not move. That is static equilibrium. Because the body will remain static. It will not move right, it will not move up and down, it will not move any direction, and it will not also rotate. So that is the condition of the static equilibrium. It will help us to determine external reactions and other internal forces to keep the body under static equilibrium condition. So I believe we have understood what is static equilibrium. Now we can use statics. I have told Rx will be balanced all horizontal force, Fx equal to 0. I explained it earlier. So Fx equal to 0 positive, we write it like this. If we solve this problem, you see Rax and 30 key. Only two forces in the x direction. Only these two forces in x direction. This Rax and 30 key. These two forces in x direction and Ray and 100. These two forces is y direction. And okay, let me explain first. And moment is, this is a moment, this is a moment, and also this force into this distance will also produce a moment. So now let's go back. Rx will be balanced by horizontal. Rx means Rx positive clock right side, so plus Rx minus 30 is equal to 0. Plus Rx minus 30 is 0, so Rx becomes 30 keep, and the result is positive, so we assume the Rx in right side, so the answer will be like this. And if Ray, as I have told, this Ray is and 100 keep, these two are the only vertical forces, so Ray will be balanced by vertical forces, summation Fy 0, so we write it like this: Fy 0 upward positive, Ray upward positive minus 100, as this is downward, is equal to 0. Ray is 100 keep feet and it is upward. Now come moment. So we have explained Rx and Ry, come moment. So moment, this is M. What is this M? This M is actually this M. This M is actually the moment of the fixed support. I have told fixed support has three reactions. One is horizontal, one is vertical, and one is moment. So this is the moment. And there is also one moment here. And as I have told, this force into this distance will have also moment. So you see, moment M will resist. Moment M will resist and balance effect of all forces. This is moment M to rotate the beam about the point A. So this is called the moment as a reaction force. I told you. Here I have assumed moment M is anti-clockwise direction. You see, anti-clockwise direction. You can assume in clockwise direction also, no problem. So we use so far summation Fx0 and Fy0 in the previous slide. Now I'll explain the third equation of the static, that is equilibrium taking moment about a point. So if we take a moment about this point, what will come? This force will not come because this is in the point. This force will not come. This moment will come. So at first minus M. M is anti-clockwise, so minus M. Then 100 into 5 in clockwise direction. So plus 100 into 5 and 50 keep moment. It is moment clockwise 50 keep moment. So M become 550 keep feet anti-clockwise. Why anti-clockwise? Because I have assumed it is anti-clockwise and the result has come positive. So it is anti-clockwise. So I believe we have understood this. And thank you very much. The next lecture will be on free body. Thank you very much. If you have any doubt, please shoot me. Thank you.